All right, so we're pleased to present Dawn Taylor. She is a registered clinical counselor. She has her master's in counseling psychology. And in addition to running a private practice and working for a local nonprofit specializing in the assessment and treatment of addictions, she provides consultation and training for frontline professionals on adolescent substance use, mental health risk factors, and intervention strategies. And her topic today for us, although she's presented to the FDN several times, she's awesome. We're really happy that she's here and kicking off our series. Her topic today is how does your nervous system and brain respond to trauma? And so, Dawn, I'm not going to go into too much further detail of your content, but we welcome you here and we look forward to sharing this hour with you.
Thank you. Thank you. Thank you. Okay, so I'm going to share my screen here and bear with me. We've done a run through of this, but if I'm going to do this and okay, how's that look? All right, yay. So it is so interesting, and thank you, Nats, and thank you everyone for inviting me into to do this. I've actually been wanting to do a bit of a conversation and a dialogue around this topic for quite some time now. I've been using this content with my clients, both with my teens and my families, my parents, they have received it so well. And every time that I introduce it, I'm just kind of evolving and changing it, just continuing to work with it and work with them. And so you'll see as we go through that you can work with the content, and we can get a little bit more into that maybe at the end with questions. We can work with the content depending on the ability of the youth, the client, the caregiver, a friend, a family member, whoever it is, their ability to sort of be able to consume the information. So let's jump right into it. So we're going to get into this nervous system stuff. But first we need to understand how our body reacts in stressful situations. So, and it's doing these things, it's reacting without us even thinking about it. So what is this autonomic nervous system? This is the part of our bodies that we don't consciously control. It's the heart, the digestive system, the lungs, the organs. So I don't think to myself, Dawn, you better make sure that your heart keeps beating tonight. Otherwise, I would never go to sleep again. I'd be so stressed out. And that for me would, like, you know, I'm actually a little bit of a wired person anyways to begin with. So, this little slide, I just wanted to show what we typically think of our nervous system as. We think of it as kind of two parts. And so most of us are familiar with this, the sympathetic and the parasympathetic. So the sympathetic is the fight-flight system, right? And the parasympathetic is typically what we call rest and digest. So it's when we can chill out, we can relax, we're digesting our food, and you can see in this list of things all the things that it's doing without our control, without our knowledge, right? So traditionally, we do think of the autonomic nervous system as being divided into these two states. So, and we often think of them as being in conflict with each other. So, I mean, you, as you can see here, you have like either Bruce Banner or you're in your Hulk state. So you're either in your parasympathetic mode, which is what we can call our social engagement mode. Here, so you can relax, you can Netflix and chill, socialize, you get the idea. Or you're in your Hulk mode. And so, as we said before, this is your fight or flight. And we include the anxiety mode in this. That is one of those responses in that sympathetic mode. And so, but unfortunately, we've been looking at this a little bit incorrectly. So there's a theory that has come out a number of years ago, and this this really explains exactly how our brain and our nervous system are working below that surface, the level of consciousness. And how this works is actually much more interesting than just the two halves, sort of, you know, that look like they're competing. So, but in order to understand this, we want to go kind of back in time and look at the autonomic nervous system and how it evolved in the first place. So the thing that we have to remember, and I say this to my youth all the time, that your autonomic nervous system has one job, and it's to keep you alive, to keep your organism alive. So that's an important, like, it is such a key point to this, because what we do is we often, the story that we come up with, the explanation, the context, that's the thing that we use to explain why we're feeling and reacting. The autonomic nervous system doesn't care about any of that. So if we think back to prehistoric times, when we were just surviving in the wilderness, I'm sure that we looked like this. We don't consciously think, holy smokes, I think I should probably run because this tiger's really gaining on me. You just do it. You just react. You just respond. I'm sure that we can all think of many, many, many times in our lives when we have just, you jump, your startle response, or you react in a way that you think, where did that come from? I remember I was going on a hike once. I was working on this ranch in Montana, not a lie. So I was going on this hike, kind of up this mountain, and on my way back down, I didn't hear it. I only felt it, but my body, I reacted with a startle response, and I started to run. And what happened was, either it was an eagle or a hawk, something was dive bombing me. I must have been too close to its nest, and it came twice, but it came from behind. And so it came, and I couldn't even hear anything. And it almost felt like the wing clipped me, but holy smokes, did I make it down that mountain pretty quick. So that was my fight or flight response, absolutely in action there. So as we said, it's acting immediately and instantly, and it's doing this for us. So we think of this system as being within our control somewhat, and that we have the ability to send resources to it, but it's really not that simple. So if it was that simple, if we had time to think about it, we might already be dead, depending on, you know, what was happening. So this is not neuroceptio. That's supposed to be neuroception. So my bad there. So, and the way that we do this is by scanning the world around us, with all of our senses acting on our behalf. So we are looking for signs of safety and danger, and we're using that information to help us stay safe. These signs that we receive, they begin a cascade of effects throughout our body that we're not even aware of. So this neuroception, which is a term coined by Stephen Porges, I'm sure that many of you have already heard of Stephen Porges and looked at his work. This is the way that we keep ourselves safe and alive. So every time you meet someone or you go somewhere, your neuroception is working underneath the surface. It's scanning whether or not this person is safe or they're a threat. And the answer to that question, it really tells us everything about this entire system in our body and how we can move through it. So the other thing that I remind my youth and parents about is that neuroception is instant and it's automatic. So we don't always think to ourselves, I'd like to open up to this person because they look nice, they sound nice. It just kind of happens, right? I'm sure that you have come across many, many people like this, where you have almost an automatic response. You're pulled to them or you are repelled by them. You just get this feel, right? We call it spidey senses lots of times. So this, even when we meet an animal, we're doing this. We are automatically scanning to see if that animal is safe. And this is my little puppy, and she's actually she just woke up from her nap. She decided to not follow her nap schedule today. So, here she is. Time to go back to sleep. So your body is just sort of knows what response it needs to do to keep us safe. So depending on the sounds that we hear and the lights that we see, the feeling that you get, right? I think we all get the idea here. So this is the ability for outside forces to impact us in this way, and it feels out of our control a lot of the time. But once we learn about this system, so hopefully by the end of this talk, you might have a little bit of a better idea. Once we learn about this system, then we can learn to identify a little bit more about where our baseline is, and also that we do have some control over this. I'll get into that a little bit deeper as we go. So, okay. So we know that it's not necessarily just these two states, right? Which will, we often think of the green as relaxed and the red as the sympathetic, which is the fight or flight. So in fact, actually there are 3 states. So this is where it gets really interesting. And the deeper I go into my research with this, I'm just amazed at how our bodies respond in these situations. And so just like a traffic light, every time you meet a person or a situation where you're like, whoa, what the heck is going on? This doesn't feel right. Or you're at the grocery store, you're buying avocados, someone is invading your personal bubble. I mean, you might feel like you have to remind them in a very sort of non-Bonnie Henry kind of way to like get out of my space. I mean, we're sort of inundated with this right now. I'm sure that many of us can relate to this. Even going to the grocery store can feel pretty stressful. So obviously when someone feels safe, that's when this green light comes on. And when someone feels dangerous, then the yellow light hits. And when someone feels even more dangerous, that's when that red light comes on. So this is our autonomic state. Our body automatically goes into either the yellow or the red. It's completely involuntary, and it changes everything about what we know about this, human response that we have. So you might not turn green like the Hulk. And you might question why you froze in certain situations and why you were able to act differently in others. And what happens is the further up towards red that we go, the smells smell differently. Sounds actually sound differently, because the inner ear actually changes the more activated we become, the more threatened we feel. So the same person who is safe and caring to you might appear differently if you are actually perceiving threat. And I'm sure that we've all experienced a time when we were in a fight or an argument with a loved one, someone that we trust, and it just felt different. Sometimes I hear this a lot with family members and even couples who say when they are in the heat of an argument, one or both people might say, I can't even hear you right now. And to a large extent, that's actually true, because the inner ear is changing the more activated that we get. So in this green state, this is our rest and digest, our social engagement system. So the heart rate slows down, saliva and digestion are stimulated, and so obviously that's what we call it, rest and digest. So the cranial nerve that activates the facial muscles is working. So we can talk to people. So we have more emotion and more facial expression. And I mean, remember when you had to do that public speaking thing in grade 6, and how much expression did you have in your voice? I mean, public speaking is something I absolutely have had to grow into and practice. It does not come naturally for me at all. So in this state, we also have increased vocal prosody and eye contact. So this is, again, this is really cool because these inner ear muscles are changing. They're picking up frequencies. They're actually picking up the human voice. And that's why even in a crowded place, we can hear the human voice. And it is set up that way in our nervous system for somewhat obvious reasons. Okay. So let's move into this yellow zone. So this is our fight or flight. This is the sympathetic. So this is where our heart speeds up, pain tolerance goes up. Our facial affect starts to become flatter. So I actually have, I've worked in the high school system, and I've talked to many teachers who find that youth in their class, when they become activated, angry, frustrated, their facial expression will start to become a little bit flatter. The middle ear muscles start to turn off. So we are better able to hear high and low frequency. And what that really means, think back to, thousands of years ago, those low frequencies are actually a predator sound, right? So think of like some kind of like a lion when it's stalking its prey, that low growl that it might make. And the super high frequency is meant so that we can hear the screech of another, whether it's an animal or whatever it is. So this is what we call an I can state, meaning that you still can move your body and you can still get yourself safe. The pupil size increases and the oxygen goes to the vital organs, only the organs that are necessary. Okay. So this is this third zone that we're going to really look at more in depth here. So this red zone is the life threat zone, and this is where we freeze. So in the past, we have grouped together fight, flight, freeze. That's usually what we think of this autonomic nervous system. And so what we want to do is think of this as a hierarchy. So this hierarchy, the freeze state, is actually at the very top. So the nervous system, and again, as I explain this to my youth and my clients, I explain it exactly like this. Your body, your organism thinks that you are about to die, or it perceives that you could die, that there's a life threat. So that is why we go into that freeze state. So there's no running, there's no fighting. And this is where, now you can see from this list here, I'm gonna show you another slide in a little bit, and it will explain this a little bit further, but this is where we also have clients who move autonomically, so automatically into this freeze state, and if they stay there often enough, they will experience dissociation, numbness, depression, hopelessness, helplessness. These are all emotional and biological states that come with this, with kind of living in this zone for a while. So neuroception is really the difference between someone who is charming and someone who's creepy. So we often meet people that are charismatic, easy to chat with, and others that are just plain creepy. And you can think about who those creepy people are. They have a flat face, little facial expression. They're just not very friendly. They're a little scowly, maybe a lot scowly. I could think of, you know, a neighbor down the street who was pretty scowly. If you hit the baseball in their yard, it's staying there. I'm not going to get it. So this is what our neuroception is doing. It's scanning all the time. So again, it is below the thinking parts of the brain until hopefully after today, right? Then we'll do a little bit more intentionality around this. So it's listening to what's going on inside our body and in our muscles and actually even in our organs. It's listening to the environment around us. And then it's listening to what's going on between those two nervous system states. So it's looking for safety so that we can co-regulate with others. And actually, we know that getting this wrong can sometimes be dangerous. So, I mean, obviously, this is a pretty extreme example here of Ted Bundy. He was, you know, the criminologist in my mind this guy comes to mind because he is, as you can see from the picture on the left, you know, if you come across someone like this and they are charismatic and friendly and engaging and it pulls you in, and your nervous system will feel that sense of relaxation. Now, it doesn't mean that we need to mistrust. Our nervous systems are actually geared more towards mistrusting than not. So our neuroception is already automatically kind of doing that. So so we have that bias to seeing things as being more dangerous than they really are. So the red response is actually the most ancient response. And so this nervous system, it settles on the state in reverse evolutionary order. So what that means is that the more danger that you perceive, the more ancient your response. So then therefore, the less ability that you have to really control. It's just going to choose like that in a nanosecond. And this slide here, this next one actually really describes, I hope that you can see that. And again, I think that everyone's going to get a copy of this slideshow so that you can, yeah, okay. I'm going to send that out. So as we look here, and as many of you have guessed, we're talking about the polyvagal theory here. So, this autonomic nervous system that we're looking at has 3 organizing principles. So the first one is hierarchy, which we just finished talking about. The body's going to choose. So if your organism believes that there is enough of a threat to your life, then it will just choose to go into a free state. And the hierarchy, the hierarchy is what Stephen Porges discovered. And that's why this is called the polyvagal theory, because he discovered that the vagus nerve, which is the main component of the parasympathetic nervous system, is actually divided into 2 parts. So there is the ventral vagus, which is down in this green zone, the ventral vagal, and then the dorsal vagal, which is the oldest. It's up here, it's in the red. So the dorsal vagal is this freeze state. And in between these 2 responses is this yellow zone, which is the sympathetic nervous system. So if we think about this hierarchy and we start in our ancient response pattern, which is the dorsal vagal up here in the red, this is the part of our system that takes us to shutdown and into collapse and dissociation. And this is where disconnection really becomes so apparent. This is when we are isolating from other people, we're not reaching out. You know, sometimes we're going into like a 3-day Netflix kind of binge where we're just shutting everything down. So, and I'm hoping that you can see on the right-hand side some of the smaller print things that are happening here. So there's decreased heart rate, decreases to the blood pressure, your temperature goes down, your facial expression and eye contact goes down. So you'll get the slide. You can have a look at it closely. So the sympathetic nervous system actually comes online after this freeze state, after the fight or flight response is our mobilizing response, right? So it's the thing that gets us moving. And about 200 million years ago, so just a few days ago, the ventral vagus came online, and that's this mammalian feature, so this social engagement down here that allows us to connect with each other. So when we're connecting with people, our ventral vagus is actually reaching out and connecting to other ventral vagus systems. And that's what we call co-regulation. So this, I also combine this approach, this theory, this system with doing attachment work, right? With a parent and a child. We talk about co-regulation as not always staying in this green state. I mean, that we would think that would be the goal, but that's actually not the goal. We know that that's not realistic, because we all go through this fight or flight, and at times this freeze state, and some of us more than others. So what the goal is to be able to, when we are moved from ventral, to be able to assess where we are, and then to be able to apply some tools, really, really simple tools, to be able to bring us back into ventral. And we can do this, we can co-regulate with other people. I mean, we know this with our children, with our loved ones. We know that we are actually co-regulating with our coworkers. Now, I have yet to see any research about how co-regulation happens online. And with this kind of medium that we are all forced into doing, and I'm going to assume that it's perhaps not as effective, but it doesn't mean that it can't happen. I mean, I've had some pretty hilarious Zoom calls with my girlfriends, and I feel pretty darn connected. So, okay. So the vagus is divided into two parts. So the ventral vagal pathway and the dorsal vagal pathway, which is that screen that we looked at just a second ago. The ventral vagal pathway responds to cues of safety and supports feelings of being safely engaged and socially connected. In contrast, the dorsal vagal pathway responds to cues of extreme danger. It takes us out of connection, out of awareness, and into a protective state of collapse. So when we feel frozen or numb or not here, the dorsal vagal has taken control. And I use this language with my clients, especially my clients who have been through a lifetime of trauma, any type of trauma. They don't understand why they froze. We will hear this from victims of trauma, victims of sexual abuse. They do not understand. They wear it so heavily on their shoulders that they froze and they didn't fight. And we've seen this for years in our criminal justice system, where people have been blamed for not fighting back. This is why. This dorsal vagus nerve takes over. So when we're in a state of feeling good and safe, the ventral vagal pathway, it oversees the system, it's as if the ventral state is able to hold the sympathetic fight or flight and sometimes the dorsal in a warm embrace, because it can hold the other two pathways. When it can hold the other two pathways, then they're not feeling so alone and needing to take over. I'm going to get a little bit more into that. So now, what we can actually recognize is that many of us, we know that we're in ventral the vast majority of the time. Then we have what we can call sort of our secondary home, which is either dorsal, which is the freeze, or sympathetic, which is that yellow zone, that fight flight. So some of us will land secondarily in this dorsal, more of in this free state, and some of us will go into sympathetic when we are feeling stressed. And this really just has to do with the childhood piece, right? Where our body just chose, our nervous system automatically chose, nope, this is bad enough, we're going to go into dorsal, we're going to freeze. This is this bad, it's that activating. Or it's not as bad, it's not a life threat, I can stay in fight or flight. I know for me, my secondary home is sympathetic, is not necessarily that dorsal vagus. I've, certainly have experienced that at different points in time, but I stay more in that sympathetic place. Whereas many of my clients and some of the youth that we have in our care and that we work with, they might go more into dorsal. So that if that's ringing true for any of you, you might see that these folks are struggling more with feelings of hopelessness. They feel helpless, they're numb, they're dissociated. It's that whole shutdown state. So there'll be a test on this later. Just kidding. Just put y'all in sympathetic. So just really quick here. So we have this one long cranial nerve that comes out of the base of the skull, and it has lots of different circuits that go to many different places in the body. So the one pathway, the ventral vagal pathway, goes from the brainstem to the side of the neck, and it helps you with your speaking, helps you with your breathing, your swallowing, your lungs. It goes to your heart. So this ventral vagal pathway is really the heart connection, and that's why obviously we call it that social engagement system. The dorsal vagal, the dorsal pathway, goes below the heart and your lungs, and it actually goes below the diaphragm and works with the digestion. So it can shut down that digestion. And this, by the way, is also the reason why lots of children, when they are feeling anxious and stressed in elementary school, they will say, "Mom, my tummy hurts, I feel sick, I don't feel good." And, of course, nowadays, I think that we are becoming more and more aware that this is an anxious and a stress response. We know that it's a somatic manifestation of that, but this really actually explains why that is. So when the ventral vagal is overwhelmed and it begins to go offline, so either sympathetic or dorsal is taking over, then it loses its ability to keep the rest of the system in check. So this theory proposes that there is that predictable order in which this nervous system works. And so when so we can really begin to understand that this is our biology. And this is one of the best ways to explain it to youth. Even youth that might have a hard time. Obviously, I'm not going to show them, pictures of their nervous system. I might show a really simple picture. Actually, this next slide is one that I have shown lots of youth, because this one, you can see this ladder. So at the very top here, now the way that this ladder was constructed, it is in reverse order of the slide that I showed with the red and the yellow and the green. So, but this one actually works really well with youth. So up top here is our ventral, right? Our ventral vagal activation. In the middle is our sympathetic, our fight or flight, and then dorsal at the bottom here. So, and so I know that I'm sure that some of us might be asking, well, you just finished saying that these responses are below our consciousness. And yes, to a certain extent, to a large extent, it is, because when our neuroception perceives that something actually is that life threat, then we move into an implicit response and we don't have the same ability. So, okay. This ladder, sometimes I will actually just draw it for kids. I'll just get a nice big blank piece of paper and we'll just draw. And at the very top, I might only choose one or two of these words depending on how much ability my youth has to really sort of consume this. We want to go obviously at their pace and what they're able to understand. And really the focus is also, especially for folks that struggle, they are stuck in this dorsal place, stuck in that depressed state. And I really explain to them that this, in a lot of senses, is outside of your control, except for, and then these little skills that I'm gonna talk about in just a minute. There's little things that we can do to help keep, there's different ways of explaining it. So sometimes I will say, you know how when you're running a bath for a baby and you stick your finger in the bath water just to check the temperature. So I explain this nervous system much the same way. Even when you are in dorsal shutdown, you can still have a finger in ventral. Now, there's little tools that we can help teach our youth and that we can learn ourselves if we find that that we are in that dorsal place and we're really stuck. What we want to look for is a flicker, as if the light has just flickered on, a little flicker of the ventral, like a moment or a second where we don't feel quite so overwhelmed. And that is when that ventral system can come back online. But of course, there's a process to go through, and we have to be really, really patient with ourselves. And so we can do this, keeping a finger in the ventral state by building up what's called our vagal tone. And so again, this vagus nerve is a cranial nerve. So it acts as a bridge between the brain and the heart. Vagal tone is the impulses sent by the vagus nerve to inhibit the heartbeat. So it acts as a brake for the heart. You'll often hear this term ventral brake or vagal brake. And so this brake is activated when we are stressed, when we're in sympathetic or in dorsal. So when we work towards strengthening our ventral state, we are strengthening our vagal tone. So it's the same thing. So strengthening ventral state is strengthening our vagal tone. So and all that really means is that we are working the nervous system muscles to get them in shape for the big event. That's how I describe it to my clients, is when you're talking with me, you might feel really relaxed. We're having a good time. We're chatting. You know me, good environment, all that. What we want to do is start to prepare ourselves for when we will experience that sympathetic or the dorsal shutdown. And how do we recognize when that flicker of ventral has come back online? So grounding techniques, amazing. Diaphragmatic breathing. Oh, I said it. I always have trouble with that word. Diaphragmatic breathing, chanting, singing, These are all things that help create vagal tone. I wish I had known this years ago when I started doing public speaking, because I was so stressed out and I was in a complete sympathetic state, vibing on the inside. But what I realized, and through doing my research, what I realized is halfway through my presentation, I would start to calm down. My entire nervous system would calm down. And what was happening is my ventral vagal was coming online because I was talking. So when we do the deep diaphragm breathing and we exhale for longer than we inhale, that activates ventral. So that's why, that's the whole reason behind even in yoga and mindfulness practice, that's why we breathe out for longer than we breathe in. And so I tell my clients, even if you count to 3 when you breathe in, just count to 4 when you breathe out. Keep it really simple. I know there's lots of really specific breathing techniques and exercises out there, really amazing ones online that you can access. So again, we have this propensity towards either the sympathetic or the dorsal. And Deb Dana, who is a therapist who has taken this polyvagal theory and really applied it to clinical counseling work. So she calls this that, you know, our home away from home. And that's kind of why I called it sort of that secondary home. So, okay. Just being aware of the time. It's okay. I'm going to blast through these last couple little slides here. Again, there's a test later for this one. Okay. So this one's a little bit intense. I apologize. But there's a good takeaway here. So really quick. So vagal innervation just means that the vagus nerve is getting the nerves, the little branches, to do their part. So that's all that means. HRV is heart rate variability. So this is the variation in the time interval between consecutive heartbeats, and it's in milliseconds. So if all you take away from this slide is heart rate variability, what we want to look for, and actually I was gonna put on a slide about healthy numbers, but I decided to scrap it. You can Google that. A normal healthy heart does not tick evenly like a metronome. So what we look for is a constant variation between the heartbeats, and then we measure this. So we want, with heart rate variability, we actually want a longer, like a bigger number in between. That shows that we have. So this can actually be a really good indicator when our heart rate variability is higher. That shows that we have better vagal tone. And here we go. I'm sure that we can all relate to these two pictures, either with our own children or the youth that we've worked with. Obviously, these are very sort of binary photos, and it's so normal for children to have moments. We all know that when they're activated. And so really what we look for is this process. What we want to do is do this co-regulation. The child is going to activate. Now, we might go up just a little bit. We're not going to join them up here, but we're going to come up just a little bit, especially if they're in sympathetic. We're going to come up just a little bit just to let them know, I hear you, I see you. It's understandable why you are feeling this way. And then we're going to kind of stay here, and we're going to wait for them to come back down. That is that process of co-regulation. Think of a turtle going into its shell. How do you get a turtle out of its shell? Do you knock on the shell? No. Do you shake it? No. We just have to wait in time. And this is literally that biology in action. Okay. And this is my last slide here. So if you look at this, I'm sure that many of us are already doing these things on some level. Hopefully you can read that, but you'll get a copy of this. And now, hopefully knowing a little bit more about the system, now we can do these with intention understanding the biology. I've had so many youth over the years who have been taught mindfulness. They have been taught the practice of mindfulness, and they haven't been taught anything about the biology. So they think they are highly critical and resistant to learning about deep breathing. Like, why would I want to? And since sometimes doing the deep breathing can actually be more activating for these kids, because if they become more aware of their body, it's actually more activating and stressful. So, so I go in really small steps. I'm helping them assess for themselves, where's your second home away from home? Are you mostly in dorsal in that shutdown? Are you in sympathetic? So, and we would do different types of grounding techniques based on where they are. And so, yeah, so you guys can read through these ones here. I really like, which one is it? Which one? Oh yeah, this one, the cooling off. Oh, this one, yeah. I've had, in DBT, dialectical behavioral therapy, one of the exercises that they teach to help change an extreme emotional state is to go grab an ice cube and hold it in your hand. So that would be this one, this cooling off one. The connection part for me is huge. Not everybody is like that, right? We've got people who are more extroverted, introverted, but for our introverted folks, it's really important. That doesn't mean that isolation is preferred. We might need isolation for a short period of time to help the ventral system get back online. And then what we want to do is we want to do engagement, but for folks that are more introverted, it might just be with one person, right? It doesn't have to be around 20.